Hey everyone, today we're going to be continuing to talk about factoring polynomials. So this is day 2. There are 2 things from day 1 that you're going to want to have handy. One is the flowchart that shows you how to, after choosing the number of terms, figure out which type of factoring that you're going to be using. And the second thing is the list that we made at the beginning of our notes last time that talks about the methods of factoring. So remember that last time we talked about these first 3. Today we're going to focus on the last 3, but some of the first 3 will still kind of come into play because we're going to need to do more than one thing to factor our polynomials. So today we'll be focusing on difference of cubes and sum of cubes. Those equations are a little bit bigger than the difference of squares because of the cubed part here. So we will start out with either an a minus b or an a plus b, and then we have a trinomial here and here. And then we will also talk about grouping. So let's go ahead and get into our first example. We have x squared minus 125. And we want to check and see if there's a GCF, and I don't see one. So let's go ahead and take a look at this a little bit closer. I see that I have a cubed here. So I'm going to be looking for something that has to do with cubes. I also notice that I have 2 terms here. And 125, there's something special about that number. And we want to think in terms of, hey, we've got a cubed here. Does this happen to be also a perfect cube? And it is. It's the perfect cube of 5. Because if you take 5 times 5, you get 25. Multiply by 5 one more time and you get 125. So I am noticing right off the bat that I have 2 perfect cubes with a subtraction sign between them. Let's use that information and go to our flow chart to see what that leads us to. So there was not a GCF, but I have 2 terms left after I checked for that. Remember that my operation was subtraction. There was a minus sign there. And both terms are not perfect squares, but they are perfect cubes. So if they are perfect cubes, we will use the difference of 2 cubes to factor. Notice that with the 2 terms in general, the only time that we're going to be able to factor those is if we have perfect cubes, if it's an addition, perfect squares, or cubes if it's subtraction. So when we notice 2 terms, we're immediately going to see, are they perfect squares or cubes before we do anything else? Now that we know that we've got perfect cubes, we are going to be using this equation right here. A cubed minus b cubed, we have 2 perfect cubes, and that's going to be equal to all of this. So what we need to do is identify a and b and then plug into the equation. So let's come back down here. I'm going to rewrite the difference of cubes equation down here for you because I know that it's in your previous day's notes. So let's take a look. I'm going to say difference of 2 cubes. And if we have something in the format of a cubed minus b cubed, we can say that that's equal to a minus b, and then a squared plus ab plus b squared. That's the equation that was up above. I want you to notice something about this. We're going to try to help ourselves remember how to set up this equation without having to memorize every single little detail. So one thing that you will notice with this difference of 2 cubes is that this sign right here is negative, and so it is the same signs as the negative that we started with. So it's got the same signs, and I'm going to underline the S for same. Notice that the next sign that we come across is an opposite sign. So whatever I had to begin with, a negative, this is now a positive. And that's the same thing for sum of 2 cubes as well. You're going to see a plus sign here to match and a minus sign to be opposite. Finally, this plus sign, whether we're doing difference or sum of cubes, is always going to be positive. So always positive, and I'm going to underline the A and the P for always positive. So notice that I have spelled out the word soap. Same opposite, always positive. So that may help you remember how to set up difference of two cubes versus difference of two squares. Now, what we want to do is figure out what our a value and our b value are so that we can plug into this equation. So I need to take the cubed root of x cubed to determine my a value. And so a is just going to be x, because if I multiply x by itself 3 times, I get x cubed. B is going to be the cubed root of 125. What can I multiply by itself 3 times to get 125? And the answer is 5. So B is 5. Now we're simply going to plug into the equation. So everywhere that I see A, I'm going to put an X, and everywhere I see B, I'm going to put a 5. So I start out with A minus B. So that will be X minus 5. The next parenthesis starts out with an a squared. So my a value is x. I'm going to plug in x squared. Then I have plus a times b. X times 5 is 5x. And then finally I have a b squared. My b value is 5. I'm going to square 5 and get 25, and that is my b squared value. One thing to know after we have done our difference or sum of two cubes, we have a quadratic here, and your temptation is going to be to try to factor that further. However, I will tell you that once you've done difference or sum of two cubes, the resulting quadratic is not ever going to be factorable. It's always going to be an unfactorable quadratic. So you're never going to be able to come up with two things that multiply to be a positive 25 and add to be a positive 5. It's just not going to happen. So we won't be able to factor that. Our other term is a linear term, and so we are done. Even though this looks kind of ugly and we feel like we should be able to do more, we're not able to do so.